And we're back. So this is part 2 of making these two wheels for the Geneva mechanism that we're gonna make. Again, I'm not gonna assemble it like this just yet. We're gonna do it definitely. So if this is something that looks interesting or fun to you, we're definitely gonna get to it. And it's gonna be in the assembly series, and I'm gonna show you some other stuff too. I think we talked about doing motion skeletons. I'm going to show you how to do those as well. And if you don't know what that is, don't worry about it. But if you have done SolidWorks before and you're doing Creo, motion skeletons are what motion skeletons are in Creo what sketch blocks are in SolidWorks. So it's essentially the same thing. But let's get to this. So now we're going to make the drive. I already have the dimensions calculated again. I'm going to mention it again. This website is where I got all the equations for the calculations. And just follow it along. I'm going to link it in this video as well. I've sent these people an email just telling them that I'm using this website. Hopefully they don't get angry. I really don't want them to get angry because they got some nice stuff here. And alright. Okay. So, that's not. Alright, there we go. Minimize. So let me just get rid of this. We'll make a new part and we'll call this drive. Geneva drive. I'm typing with one hand, so it's kind of slow. Alright, so, okay. Geneva drive. Let's make the part. I'm going to show that. Select a plane. This is my standard thing that I usually do. You know, I change it to static, and that's like my routine before I do anything, because everybody has their little things they set up before they start modeling things, and this is mine. There's a few more things that I'm going to show you in the advanced stuff to set up, but we'll worry about that when we get there. Alright, so let's make that drive, the green side. I already have the calculations done, so I'm just gonna start modeling. Again, I recommend you make your own. So our outer radius. Oh, this is good. This is good to show, I guess. So you see two layers here. We got this bottom layer, and then we have something that's on top of it. The diameter of the bottom layer is something that you decide as well, and it's not in these equations or parameters. So just be reasonable about it. The way I like to think about it is the diameter where this pin is placed. I just go about an inch or about an inch and a half further, because you have to take into account the diameter of the pin itself. So if you go an inch further, you only have like half an inch of clearance. So that's what I recommend. But I'm gonna make the circle now, and let's make it to be. So we have 8. I'm gonna make it to be 10. 8 is the inner diameter. Okay. This is going to be the bottom part. I'm gonna make another line now using construction mode, and this is where the pin's gonna go. Actually, before I do that, let me just make the bottom disc like we did last time. Extrude that out. 0.25, just arbitrarily picking a dimension, and then we're gonna sketch on this. Select the surface, select the face. If I'm doing this too fast for you, chances are you haven't seen the beginner tutorials. Just follow along. The way I'm moving this around, hold down Control, then click middle mouse button and drag it. That's how you do this. You should already know how to do this. Middle mouse button, drag it around. That's that, and when you get lost, just click this. Okay, so construction mode. Again, I'm going to select the reference, hold on Alt, click the edge that you want the reference to be, and now we have this dimension, and I want it to be about 1 inch down, but that's not how we do it, is it? I want it to be about 4 inches from the origin. Okay, that's that. So at this point I want to make the pin. Now I can turn off construction mode, and now it's gonna snap at the end of that line. And there we go. It's 1 for me. I don't know what it is for you, but it's 1 for me. And okay, so what I could do now is make the inner disk that's gonna have the connection. It's gonna interface with the wheel itself too, the middle part. But I'm not gonna do that. There's a reason for that, and once we get into assemblies, I'll explain what the reason is. But right now, it's good to, or I should say, it's actually good to not have too many extrusions within the same extrusion. It's good to kind of do extrusions separately, because then it's easier to kind of manipulate them, and then when you get into assembly, it's easier to interact with them as well. So what we're gonna do is we're gonna make this part separately. So let's just do this for now. I'm gonna have it extrude out about, let's say, 1/2 inch. It's that too small. 1 inch sounds good, looks good. And now I'm gonna create the other side. Let's see. So the radius of the inner wheel was something, again, calculated already. For me, it was 2.49. And if you remember us making a cut into the wheel from the last video, that's exactly the size of that as well, and that's for a good reason, because that's what it's supposed to be. 2.49 times 2. Another thing, in these dimensions you can have these mathematical operations, so you can do 2.29 times 2 or plus 2.49, whatever you want to do. So it can handle some operations, so you can have parentheses in there too and all that stuff. It's pretty nice feature. I'm gonna leave it like this, and once we get into some of the advanced stuff, you'll see exactly how to set these up so you can produce many of these Geneva gears without having to create them over and over again. All you would have to do is just change a few dimensions, but that's for later. I know I'm saying a lot of stuff is for later, but trust me, it's coming and it's gonna be fun. But this is it for now. Let's just extrude that out. Oh, nope, that's not it. If we remember, right here, there's a little slice in here. We're gonna have that slice cut. So let's go to the sketch again, edit definition. I'm just kind of eyeballing this right now, and I'm gonna use the spline tool. It doesn't really matter whether it's too far down, as long as it doesn't interfere with the wheel. So if we look at this animation, this doesn't interfere with the wheel. It's far enough that this is allowed to rotate, and that's really the only crucial thing we have to keep in mind. That's really, it's not really important for any other purpose, because there isn't going to be much. And again, if you're engineering students, you should understand this. There isn't going to be much force exerted by the wheel on this, because it's just stopping it. There's nothing really pushing against it. It's just there to hold it in place. So it doesn't have to be too thick. So it's fine the way it is. You can even have something crazy like what I'm about to do now. So you can have something like this too if you want. We'll do that actually. Why not? Let me actually mess around with some constraints here. Okay. Horizontal. Make it horizontal. Make that horizontal. Oh, well, how about this? Let's try making it perpendicular. Whoa. Alright, well, that's not gonna... Oh, is this... Oh, because I made a spline, that's why. Okay. Let's make this line right here, and we're gonna make it horizontal. That's that. We're gonna get rid of the extra stuff. We're gonna get rid of this extra stuff inside, and that's it. And we're gonna extrude that out. So you can have something like this, though it doesn't have to be a solid piece. And I'm gonna do that. let's make it the same as the other, the same as the pin. What was it, 1? Oh, it's 1. So it's gonna be, yeah, it's about 1, it's the same. And of course, as I said last time, we're gonna punch a hole through this 2, because this is the one that's gonna have a motor on it. When we get into the advanced stuff and I make this again, we're gonna have something called a key. You need keys in things like this. Well, you don't need it necessarily, depending on what you got, but keys are, you know, kind of required. So let me just show you. That's not what I was looking for. Motor with key. That's, nope. Motor with shaft key. Okay, there we go. So just a little bit of lesson here. Again, I hope these image people don't get, whoever owned this image don't get angry at me. But so this is something called the key, and this is gonna fit into something, into a gear or something that's gonna have a slot for this to fit in, and that's how you would drive a key, drive a gear. Because otherwise, if you have just a straight random hole, and you put a motor shaft in there, it's solely based on friction, and there could be a lot of slipping that could occur even if it's press fit. So it's good to have keys because it's nice to transmit power that way, and it's efficient to transmit power that way. But that's we don't need to worry about that. That's just something, it's a digression. I'm gonna do a lot of those. So 0.75, punch a hole the other way to the surface, and that's it. So now we have the two components that we need to have a Geneva mechanism. This is a valid Geneva mechanism, even though we have just this thing going around it. And realistically, this, I think, will be made. And I'm talking about this because when you design, just because you can make extrusions and you can make things, doesn't mean that it's possible to fabricate those things. You have to keep in mind that whatever you make in CAD, it's gonna be fabricated, and you're making it for fabrication. So if you make some impossible looking curves that are going to be very expensive to fabricate, you should try to remedy that. And I think this is fairly easy to fabricate, because you're gonna start out with essentially a disc that's going from this lower end to this point, and then cut in all these pieces. I don't know why I said it like that, but you would cut into it, and you would fabricate this using a CNC machine of some sort, and that's how you would do it. Same thing with the other thing we made. Let me just open that up. That is not where I was. Where was I? Beginner 8. Alright, well, whatever. The other Geneva wheel that we made, it would be done the same way. Well, let's just look at this. You would have a CNC machine coming down and taking all these parts away, and that's how you would fabricate it. That's just a little thing I wanted to mention, to keep in mind that you should model with the idea of actual fabrication in mind. Don't just randomly start making crazy curves and sweeps all across the places and think that it's something you can fabricate, because it could be unrealistic. But this is gonna end our beginner series. So I went over just the basic tools, how to use them, and I've kind of showed you how to make some realistic mechanisms, realistic parts, not mechanisms really, because we're gonna get into mechanisms soon, and not soon actually, in the next video, next series or the series after that. I might want to go into parts modeling a bit more in-depth stuff like parameters, but for now I think this is good, and I'm gonna stop this. I'll see you in the next series.